Hey guys, Mr. Stevens here. Sorry I'm not there with you today, but I've just got this video for you going through the worked examples from today's lesson. Today we're going to be finally putting our simultaneous equations into a practical context. The couple of lessons we've done so far where we've actually looked at simultaneous equations, you've just been given like y equals 2x plus 3, y equals whatever, without any context around it. We're still going to be doing all the same things we've been doing with simultaneous equations, looking for the point of intersection, or if we decide to solve them algebraically using substitution or elimination that we learn on Tuesday. But sometimes we're going to have to figure out what their equations even are by looking at the practical situation in the question. Let's jump into some examples. This is an example of a pretty straightforward kind of question because it gives you the two equations. You've got our friend here buying and selling books. We have an equation for the income received for selling books, 16n, where n is the number of books. And then we have also an equation for the costs. Cost equals 8n plus 24, again, where n is the number of books. Some very straightforward questions here to start with. What's the income when 6 books are sold? Well, we just take the income equation and we substitute in 6 books and we get the answer, which I think is $96. And we do the same thing with the cost equation. We substitute in 6 books and we get the answer, which I think is 72. Let me just check. Ooh, 56. Well, no, I typed that into my calculator wrong, sorry. It is 72. I was right the first time. That's fairly straightforward. That's just plugging in a number into the equations. You guys can do that. Now we get to the part where we're actually going to solve simultaneously. I've already drawn the graph here. But just to remind you guys, if you were going to draw this graph, this first equation would have a rise over run of 16. So for every 1 book, you would go up by 16. And it's got a y-intercept of 0. That's why it's got a y-intercept of 0 down here. And then same thing for the cost line. You'd go up 8 for every 1 book you went across. And you can see the y-intercept of this line is 24. If you wanted to draw those nice and quickly. And then if you did that, you would find that the income and number of books, point of intersection there. The question asks you what are the number of books needed for the costs to be equal to the income, so the answer there would be 3. Just reading off that point of intersection. Another kind of question we can get is one like this one where we don't actually get given equations and we have to figure out what the equations are just by looking at the question. I'm going to show you how to do that. Isabella's mathematics mark exceeded her English mark by 15. She scored a total of 145 for both tests. Find Isabella's mark by plotting in each subject by plotting intersecting graphs. So it may not seem like we have a lot of information here, but we actually have everything we need. Isabella's mathematics mark exceeded her English mark by 15. So I can write an equation that says m, her mathematics mark, equals her English mark plus 15 more marks. Because her maths mark was 15 higher than her English mark. There's an equation we can work with. We also know that her total for both tests was 145. So her mathematics mark plus her English mark must be 145. And there we go, we've got 2 equations. You can plot those 2 equations. If you were going to plot those equations, you could probably do this to make both of them say m equals. So then you've got 45. You've got one equation that has a gradient of -1 and a y-intercept of 145, and then you've got one equation that has a gradient of +1 and a y-intercept of +15. I actually have that graph down here. you can see here's your y-intercept of 15, gradient of positive 1, y-intercept of 145, gradient of negative 1. And you've got the point of intersection right here that tells us that her maths mark was 80 and her English mark was 65. That's how you would do it if you were going to draw it. I also have an example over here for you to check out of me solving those two equations using the substitution method, and you can see that I got to the same answer. You guys can check through that working out. For the questions that we're doing today, I actually don't mind which way you do it. You'll see that in the questions they will tell you to draw a graph, but if you're going to solve them with substitution or elimination, you can skip that step if you'd like. I would like you to have a go at least doing a couple of them with the graph though. If you're like super comfortable with doing the algebra stuff, that's great, and you can answer some of these questions doing that, but maybe do at least 2 where you do them from the graph, please. So yeah, you guys can get into that. I'll hopefully see you tomorrow.